Hello class. Today we're going to learn to classify numbers by kind. Okay. So there are 8 number sets that I need you to be familiar with, 6 of which we will use in class on a regular basis. The last 2, complex numbers and imaginary numbers. I need you to know that they exist, but I'm not going to hold you accountable for knowing those numbers. Okay, so let's talk about how these numbers fit together. And throughout this lesson we will define these, give you examples, and then show you how you can determine one from the other. So here is kind of a Venn diagram of how all the numbers fit together, along with the letters that we use to represent each of those number sets. So you'll notice that each set here is nested within the other. So natural numbers are included within the whole numbers. Whole numbers are included within the integers, which also include the natural numbers. And rational numbers include the integers. And then you'll notice that there is a rational and there's an irrational, and they don't go together, okay, but because one is opposite of the other. And then you have real numbers that contain all of it. Complex numbers are kind of a combination of real numbers and imaginary numbers, because we would have another set of numbers out here called the imaginary numbers. Now, the natural numbers are represented typically with the letter N. Okay? Whole numbers are typically represented with the letter W, or sometimes you will see this as an N with a 0 on it. And we'll find out why in just a few minutes. The integers are represented by the letter Z, and I do put a bar through my Z, so just kind of bear with me on that one. Rational numbers are represented by the letter Q. Irrational numbers are typically represented with the letter I, and real numbers are represented with this interesting looking R, a double bar R. Okay, now those are the ones that we need to talk about the most. Okay, another representation of how they're kind of nested together is like a series of boxes. You'll notice rational numbers contain integers, which contain the whole numbers, which contain the natural numbers. And irrational numbers are kind of this box down here below with this big frame, the big frame here representing what we call the real numbers. Okay, so let's see if we can actually define some of these. Okay, so the first one is what we call the natural numbers or the counting numbers. Okay, these numbers are the numbers we use to count by, numbers used for counting. So example, that's 1, 2, 3, 4, 5, and so on and so forth, all the way out to infinity. Those are our counting numbers. Okay, the next set of numbers that we have is called the whole numbers. Okay, and the whole numbers, okay, these are the numbers, all the natural numbers, but we add one number to it. We add the 0. Okay, and again, whole numbers are represented by the W or the N with a little 0. This means that it's all the natural numbers plus 0. That's what the whole numbers are. Okay, so the next set. The next set are the integers, which are represented again by the letter Z. These are the whole numbers and their opposites. So you'll notice that we've got the natural numbers here. We have the 0, which makes it the whole numbers, and all of their opposites. Opposite referring to the distance away from 0. Okay, so here we have a positive 3. Its opposite would be negative 3. So that's our set of integers. But so far we have nice pretty numbers. We have no decimals or fractions. They're all whole numbers and then the negatives of those whole numbers. Now, in order to bring in all the numbers that are in between this number line, like between 1 and 2, this is where we have our decimals and our fractions and things of that nature. And when we have those, we have something called natural or rational numbers. We have rational numbers. And a rational number is any number that can be expressed or written as a quotient or fraction, A over B, sometimes this is P over Q, A over B of 2 integers with the denominator B not equal to 0. So really, rational numbers are any number that I can write as a fraction. That's how I need to understand these. Any number that I can write as a fraction. Okay, here are some examples. We have 1/2. That's a rational number because I can write it as 1 over 2, which is a fraction. 0.75, I can write that as a fraction, is 3 over 4. So it's a rational number. 1 could also be written as a fraction as 1 over 1. 2, the same thing, 2 over 1. But you can also use decimals, the positive and negative versions of numbers. And this is where we bring in our fractions. Now, there's one thing that we do need to understand about this, that if I were to take a fraction such as 1 over 9, and I were to type that into the calculator, 1 divided by 9, I'm going to get a value of 0.111, and it's just going to keep going. That is a repeating decimal. Repeating decimals, anything that repeats, is considered a rational number because it started out as a fraction. So any number that I can write as a fraction, including this repeating decimal, is considered a rational number. Okay, so that's the distinction. So anytime we're given anything, what we have to do is we have to look at its decimal, the decimal value. And if we look at that decimal value, and we can determine, and I can predict what the next value is going to be, that means that it's a repeating decimal. Okay, so it will be considered a rational number. Okay, now what's the other kind then? The opposite of rational is irrational. So if rational numbers are any number that I can write as a fraction, irrational numbers are any number that I cannot write as a fraction. A real number that cannot be written as a simple fraction. The decimal goes on forever without repeating. That's the important thing. And our most famous irrational number is pi, because we get 3.14159, blah, 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 but there's no pattern of repetition. And that's the distinction. Rational numbers, there will be a pattern of repetition. Irrational numbers, there will not. So when you type the number into the calculator, it will go on forever with no pattern of repetition. Okay? Then the last set that we have to really be focused on and concerned with in 7th and 8th grade is real numbers. Okay, and real numbers are the type of number we normally use, such as 1, 15.82, negative 0.1, 3/4. So any number that can be placed on a number line is considered a real number. So this can be our rational numbers and our irrational numbers. All of them can be placed on a number line. So our most famous irrational is pi. Yes, we could put pi on a number line. So if I were to go back to my integer page with this number line, pi would be about right there. That's where our pi would be. So I can put that number on the number line. Okay, so that's why it is considered a real number. Okay, now that's as far as our lesson really needs to go today. Okay, going through real numbers. Now, one of the things that we need to be able to do is if I give you a number, you need to be able to tell me what set it belongs to. So take, for example, this negative 15. Okay, so I need to figure out what sets does it belong to. Okay, well, could it belong to the natural numbers? Well, natural numbers are our counting numbers, and they're all positive, 1, 2, 3, 4. So it won't be part of the natural numbers. Would it be a whole number? Well, for whole numbers, we only add a 0. So again, they're still all positive values. But once we get to the integers, the z, we do have our negative 15. So this could be an integer. If it's an integer, then it's going to be a rational number because I can write it as a fraction. Oops, excuse me, that's not rational. I need the Q for the rational. Okay? And then it's going to be real as well. So it would be an integer, it would be a rational number, and it would be a real number. Now, what if I use the number 11? Well, the number 11, it is a counting number. So we would start off with the natural numbers or the counting numbers. Well, if it's a natural number, then it's going to be a whole number, and it's going to be an integer, it's going to be a rational number, and it's going to be a real number. Okay, now square root of 30, if you were to type square root of 30 in, you're going to get a decimal value that just goes on and on and on and on and on. Okay, and there's no pattern of repetition. Okay, so when you look at that, that tells you automatically that it's an irrational number, but it's also going to be a real number as well. Right? Now if you did 17 over 3, this one you'll end up with 5.6666, and it just keeps going. Okay, well, a repeating decimal is a rational number. Okay, so it starts at the Q, and it will also be real. Okay, so that's kind of the distinction, and that's what I'm going to need you to be able to do in order to be successful in this particular type of concept. So we have to be able to distinguish between the numbers and what sets they belong to. So again, let's kind of review. Okay? So if we had natural numbers are our counting numbers. So if you look at the bottom down here, we've got a series of numbers. 5 would be a natural number. 0 Wouldn't be a natural number, but it's coming close. It's almost there. And this 8 would be a natural number. Now we move up to the whole numbers, and that's where we add the 0, where we would put the 0 in there. Integers, we would end up with negative numbers. Like this -6 would be an integer, but the -4.5 would not. Okay, because integers have to be, no decimals, no fractions. Okay, then for rational, we'd have the -4.5. We'd also have the 3/4. For irrational, we would have the pi. That's our most famous. And all of those numbers would be a real number. Okay, and that's what we're looking at. Okay, so until next time.